Igneous rocks and the rock cycle. Table of contents. What are rocks? Most rocks are an aggregate of one or more mineral, and a few rocks are composed of non-mineral matter. There are three major rock types: igneous, metamorphic, sedimentary. Major rock types. Igneous rocks are formed by the cooling of molten magma or lava near, at, or below the Earth's surface. Sedimentary rocks are formed by the lithification of inorganic and organic sediment deposited near or at the Earth's surface. Metamorphic rocks are formed when pre-existing rocks are transformed into new rocks by heat and pressure, usually below the Earth's surface. This is the rock cycle. Igneous rocks that form from the cooling of molten rock magma, example granite and basalt. Sedimentary rocks that are formed from the pieces of other rocks, example sandstone, or that are deposited from the ocean by chemical processes, example limestone. Metamorphic rocks that are changed by heat and pressure without melting, examples gneiss. Hey, not here. This is magma. From magma to solidification to igneous rocks to weathering to transportation to deposition to sediments to lithification to sedimentary rocks to metamorphism to metamorphic rocks to melting to magma to crystallization to igneous rocks intrusive, from igneous rocks intrusive to uplift and exposure, from uplift and exposure to weathering, then from uplift and exposure to metamorphic rocks, then from sedimentary rocks to uplift and exposure, from uplift and exposure to weathering, then igneous rocks intrusive to metamorphism, then here, then from uplift and exposure to metamorphic rocks. This is the rock cycle. The rock cycle. The rock cycle. The rock cycle. Igneous rocks. Igneous rocks are formed by the cooling of molten rock. There are two major states of molten rock: magma and lava. Magma is a form of molten rock that exists below the Earth's surface. Lava is the term given to magma once it reaches the Earth's surface, usually in the form of volcanic eruption. There are two major classifications of igneous rocks: intrusive and extrusive. Intrusive igneous rocks are formed by magma that cools below the Earth's surface. Extrusive igneous rocks are formed by the lava that cools at the Earth's surface. Intrusive igneous rocks generally cool very slowly deep below the Earth's surface, or as the magma is rising to the Earth's surface. What happens to molten rock as it cools? When the temperature of molten rock begins to drop, there is a loss of energy that causes ions to slow down. As the ions slow down, they group together and arrange themselves into orderly crystalline structures. This process is referred to as crystallization. During crystallization, the silicon and oxygen atoms are the first to link together, forming silicon oxygen tetrahedrons, which are building blocks of silicate minerals. Crystal size and cooling rates. Slow cooling rates produce large individual crystals in the rock. Intrusive igneous rocks generally cool very slowly and tend to have large crystals that produce a coarse-grained rock. Phaneritic rocks are coarse-grained rocks which contain individual crystals that are relatively even in size and large enough for scientists to identify the different mineral grains that compose the rocks. Faster cooling rates produce smaller individual crystals in the rocks. Excessive igneous rocks tends to cool quickly and are characterized by smaller grains that produce a fine-grained rock. Porphyritic textured Porphyritic texture rocks contain both a coarse and fine-grained texture. The coarse grains in porphyritic rocks begin to develop as the magma is cooling below the surface of the earth. Texture. Texture is a term used to describe the size, shape, and arrangement of interlocking crystallized mineral grains or an igneous rock. Two major factors affect the size of crystals grains in an igneous rock. First, rate at which molten rock cools, slow or fast. Second, amount of dissolved gases or fluids in the magma. Texture. Igneous minerals vary greatly in grain size. Grain size classes are similar to the sedimentary scale, but there are fewer divisions with a great range of size. Phenocrysts are grains in an igneous rock that are larger than the other grains that make up the rest of the rock. Grain size category: fine grained grain size distribution is equal to less than 1 millimeter. Medium grained lies between 1 millimeter and 5 millimeter. Coarse grained lies between 5 millimeter and 3 centimeter. Very coarse grained greater than equal to 3 centimeter. Phenocryst texture: microphenocryst 0.03 millimeter to 0.3 millimeter. Phenocryst 0.3 millimeter to 5 millimeter. Mega phenocryst greater than 5 millimeter. Igneous rock textures: phaneritic intrusive, aphanitic extrusive, porphyritic intrusive and extrusive, glassy extrusive, pegmatitic intrusive, pyroclastic materials extrusive, lava extrusive, hoi lava extrusive. Phaneritic texture: phaneritic intrusive. Phaneritic rocks are coarse-grained rocks which form below the Earth's surface. The individual crystals are relatively even-sized and large enough for scientists to identify the different mineral grains that compose the rock. This is granite rock with a phaneritic texture. This is quartz crystal which is white. This is quartz crystal which is white. This is feldspar crystal which is pink. This is bolite crystal which is black. Consists of the three crystals. Aphanitic texture: aphanitic extrusive. Aphanitic rocks are fine-grained and contain crystals that are too small to distinguish without the aid of magnifying lens. Aphanitic rocks are often described by how light or dark the rock appears. Aphanitic rocks may also contain vesicles of remnant gas that give rock a vesicular texture. This is basalt rock with an aphanitic and a vesicular texture. Porphyritic texture: porphyritic intrusive and extrusive. Porphyritic rocks contain both coarse and fine-grained texture, indicating different environmental conditions which formed the rock. The coarse grains in a porphyritic rock develop as the magma is cooling below the surface of the earth. This is rhyolite rock with a porphyritic texture containing phenocryst of overline and pyroxene and gabbro ground mass. Glassy texture: glassy extrusive. Glassy textured rocks are formed by very rapid cooling of magma. Glassy rocks often form from magmas with a high silica content that arranges into long chain-like structure before crystallization occurs. Glassy rocks can be considered amorphous because they have no crystalline structures. This is obsidian rock with a glassy texture and conchoidal features. Glassy extrusive. Glassy rocks are classified by the amount of glass obtained by the rock. Glass varies 0 to 20% glass. Glass is 20 to 50% glass. Glassy 50 to 100% glass. Obsidian is a common glassy rock. Pegmatitic texture, pegmatitic intrusive. Pegmatitic rocks contain large interlocking crystalline grains greater than 1 to 2 cm in diameter. Pegmatites are commonly composed of quartz, feldspar, and mica minerals. Pegmatites are formed from a combination of hydrothermal and igneous processes and is dependent on the presence of fluids and volatiles such as water, chlorine, bromine, sulfur, and fluorine. Examples of pegmatitic veins extending through rock. This is pegmatitic veins extending through rock. This is pegmatitic veins extending through rock. Pyroclastic materials. Pyroclastic extrusive. Pyroclastic materials form when individual rock fragments are ejected during a violent volcanic eruption and consolidate into large rock composites. When they deposit on the surface, pyroclastic rock contains at least 75% pyroclastic fragments, with the remainder consisting of other inorganic sediments or organic materials. This is tough rock with a pyroclastic material. This is tough rock with a This is tough rock with a pyroclastic material. Then pyroclastic fragments. Pyroclastic materials do not conform well to igneous grain size classifications. Instead, geologists use the following term to describe pyroclastic fragments: Juvenile fragments, volcanic eruptions formed from cooled magma before it deposited. Conglomerate fragments, volcanic eruptions which formed during the previous volcanic activity and are ejected by later eruption. Accidental fragments, rocks which are disrupted, dislodged, and possibly even ejected by the volcano but are not of volcanic origin, although they may be igneous. Bombs, fragments with a mean diameter greater than 64 mm and a rounded shape. Blocks, fragments with a mean diameter greater than 64 mm and a blocky angular shape. Lapilli, fragments in any shape with a mean diameter of 2 to 64 mm. Ash, grains of pyroclastic fragments with a mean diameter less than 2 mm. This includes coarse ash grains 0.03 to 0.22 mm and fine ash grains less than 0.032 mm. Lava. Lava extrusive. Is a basaltic lava that has a rough surface characterized by sharp jagged blocks and protruding spines of volcanic rock. Flows move slowly 5 to 50 meters per hour and are often several meters thick. Lava in highways volcanoes national park. Lava in highway volcano national park. Lava in highway volcano national park. Lava flows are common on the Hawaiian Islands. The flows move so slowly that tourists can walk up to them and take pictures. Pehoi Hoi lava. Pehoi Hoi lava extrusive. Pehoi Hoi pronounced Peh Hoi Hoi is a basaltic lava flows that has a smooth and twisty rope-like surface. Smooth and twisty rope-like surface. Smooth and twisty rope-like surface. The Pehoi Hoi lava flows move slow enough 5 to 50 meters per hour for observers to watch the cooling lava as it advances forward.